Alright, so I think we're on to part 3 of doing like our SCL videos and doing all the conversions for everything. Still breaking it down into little parts. Today we're going to try to do some if and then statements. So the block that we're going to try to replicate today would be like a timed output block. So the idea of this is to if you had solenoid valves that needed to be on for a certain amount of time, um, so that you didn't burn them up from cycling excessively or too fast, or if you wanted to make sure that an output was on for a minimum amount of time, that you would use this. It's basically a pulse timer with the option to have the output be only pulsed or to have the output quote unquote maintained. Um, so I've got it written here in ladder. I'm going to pull up HMI, simulated HMI, so that I can kind of toggle it and show what we're doing. So if I turn on this input, it's turned on this pulse timer for 5 seconds, and that's going to drive this output, which I've got down here. So this is going to be on for 5 seconds, and then it's going to go off. Now if I change this, and I hold my input, oh, 4, 5, but we still have our output on because we're still forcing our input on. If we change that, it doesn't matter. If I keep holding the input on, the output's going to come back off after 5 seconds. So maybe if you had like a grease system and you wanted to inject grease for so long, or dump something into a tank, run a valve for a certain amount of time, you might do something like this. It also forces that input. Even if you only blip it, it's going to be on for a set amount of time. Okay, so let's pull up our editor, and we want to put this next to that. So I've copied over the interface, but I guess I can show you real quick. We got our input, on time, output maintained, output, and then as a static variable we have a pulse timer. So the first run, we're going to take our pulse timer, we're going to call it, so remember, Control Shift Space, and we can bring up all of our arguments into it. For our input, we're going to move that into in. For our preset time, we're going to move time in. Okay. Now, also I'll do this today. We are going to make this area, we're going to pack it inside a region. They started doing this maybe a couple editions ago of TIA Portal, but we can give it a name, pulse timer. And now if I open this regions, I can shrink all the code that's in there, and also it'll list down everything that we do. This is great for making your code fast to look through and organize. If you have like 10 different things that you're doing, you might break it into pieces so that you can see it a little bit better. It's kind of like how we pack our networks in. So I'm going to do another region. The name of this one is going to be output logic. If you want to know how to do that, if you hold Control and you push left or right arrows, you can jump real fast like that to the beginning of each space-separated word. So I'm going to do that, and then now I'm going to hold Shift and press End, and then I can highlight all that line and delete it in one place. This is one reason I do like writing some things in SCL. I can edit and work a lot faster than if I was having to click and grab stuff. Although if you learn your shortcut keys for ladder, you can work pretty fast too. Okay, so if we look at this rung of logic down here, basically we're saying we have two different branches that we're driving our output with, and the first condition is just if we don't have output maintained, or if we have output maintained, then that dictates what branch we go down. So I'm going to make an if statement, and then I'm going to say, I'm going to put this in parentheses because we're looking at the quantity of the idea. If not output maintained, then output equals pulse timer dot Q. And that's the end of the line. Okay. We can do else, or we could do else if. Because this is a Boolean operation, we could do the else. But if a person needs clarification, actually I guess maybe for the sake of this video we'll do clarification for it. Else will grab any other conditions that are not placed in the previous ifs or else ifs. So it will try to evaluate the first condition. If that doesn't make, then it will go down to the next condition and the next condition and the next condition. And then at the end of the day, if none of the conditions are made, then we're going to do blank, blank, blank. Maybe an equivalent would be that you would write in a first rung, do this thing, and then you would have 5 rungs under it that would have specifics to do a different thing. So no matter what, you're doing the first rung, and then you'd be overriding it in your next scans, or that you would write code that has these 3 things do this, and then if anything else would do that. So I guess we'll do else if output maintained. Now my computer is snagged up a little bit. Hopefully it'll come out of it in a second. Then output equals pulse timer dot Q or input. Now remember that from the previous videos, with this option or this option turns on the output. If a person is worried about duplicate destructives, you could have 2 different temps, and you could turn on, this one would turn on temporary variable 1, whatever you wanted to call it, and this one would turn on temporary variable 2, and then at the end you may do another evaluation, which might be a good idea. This is a pretty short logic that we're going to evaluate. There's not a lot going on. I see this done quite a bit like this. Also, our outputs are here right now, so it's pretty easy to sort through. So that's generally how it's done. I guess I'll show an example of let's do output maintained trigger, output not maintained trigger. And then down here, a person might write code that would say output is equal to output maintain trigger, or output not maintain trigger. And now you've gotten rid of your duplicate destructives. You know, if a person wanted to go that way. To me, this is actually maybe a tad bit harder to read. So I'm going to put it back and get rid of these variables. Like I said, I see this done far more often than the other ways that it's. This is maybe one of the disconnects between people that write in structured text and ladder. And a person could write logic to say here. A person put a comment that says output is only driven by the pulse timer. And then you might put output is driven by the pulse timer or the input, you know, to help clarify. So let's load this up. So I'm going to call timed output SCL. I'm going to pass in the same parameters that I did before. And then I'm going to comment out this network. Okay, and then we'll download that. Okay, the same as before. If I flip on my input, it's going to stay on for 5 seconds no matter what I try to do, you know, if I keep trying to hold my input on there. So, and then if I turn on maintain output, now if I keep holding my input past 5 seconds, which it's probably been past, it'll still stay on. And we can open the code and look to see what's going on in our network. Open and monitor. Okay, so let's move this up here where a person can, I guess I could shrink this up a little bit. So right now we don't need to see those function buttons. So our input's false. The on time is a constant being pushed in. And let me open up these results. Right now we don't have a output maintained is true. So then that's going to go through this rung here. See the true there? And pulse timer Q is false and input's false. So if I turn this on, okay, we have pulse timer is true and input's true. Now our pulse timer ran to false because the 5 seconds passed, but we're still doing our input true. So then that's still going to make output true. I'll let go and see how the whole thing turned off. Now if I toggle this, this will turn green and we'll run this logic up here. Now Output's only being driven by that pulse timer Q. So if I turn this on, yep, see pulse timer Q went false, and then that drove output false. So that's how you debug and run it live like that to try to figure that out. So I'm going to have to go back and add some more blocks by next week, but we should be getting close to the point to start actually writing software for our machine. Maybe we'll cover some for loops next week to do maybe an I/O screen, or to pull information like that, or to clear out variables. But I hope you enjoyed the video. If you have questions, just shoot me a text. I guess maybe I'll try to load this up on Dropbox, this project, so that if you guys want it, you can have it and work along too. Alright, well, thank you for watching. Hope you have a good day.